actually the second time I'm doing this problem today. I lectured for that part one, and then towards the end of part one of this section, my lectures really started biting, so I decided just to start over. Hopefully, I do better this time. So each of the word problems, at some point, it gives me a little sentence or a paragraph and asks me to do a couple things. The first thing is to come up with an equation of a line or a function to model the data, and that function is going to be a line. And then it asks me to use the function to use the function I create to answer some questions. Honestly, I probably could answer the questions as easily or better without the equation, but the process of finding the equation, that's going to be important if you go a little bit higher in math, because it's super common to have to find equations for lines. So in these bank of word problems, there's going to be two styles of how I get my equations. One is the problem's going to be worded in such a way that I can easily extract 2 points, and then if I could find 2 points, I'll find the slope of the line, the y-intercept, and get a y equals mx plus b equation in a real standard way. And then some of the problems are going to be worded in such a way that I could come up with an equation logically that works without having to come up with points. And then, well, those are the two ways, and I'll have to decide which of the two ways I'm going to go. For problem 16, if I look at the problem, I see 4 numbers. When I see 4 numbers, that generally tells me that I'm going to be able, and I'm asked to find an equation for a line. There's probably 2 x's and 2 y's, and there's points buried in here. So if I read through the problem, OSU, which would be Ohio State, because I'm from Ohio, Oregon State, Oklahoma State, had 28,000 students in 2008, 29,500 students in 2010. So assume the growth is linear, create a linear function to model the data. This is a classic problem where I'm given 2 points, and I need to create my points, and I need to decide what to call the x and what to call the y. And I'm going to call the x the year, the y the enrollment, or the number of students. And it wouldn't be wrong if you said the y is the year, because y and year fit, and the x is the enrollment. Although it wouldn't be wrong, usually if there is a year, usually a year and then something that results in that year, usually the year is the x. And what I'm going to do is make my numbers smaller. For the year 2008, I'm going to use the number 8. For the year 2010, I'm going to use the number 10 to keep my numbers at a reasonable size. So I'm going to create points that model the enrollment. I'm going to say in 2008, the enrollment was 28,000 students. I'm going to call that the point 8, 28,000. And in the year 2010, the enrollment was 29,500 students. And I'm going to call that the point 10, 29,500. If you use 2008 and 2010 instead of 8 and 10, the numbers get crazy big. The video that I recorded just a little bit ago that I wasn't happy with, I used those big numbers and I really wasn't happy. So I'm doing this again, hopefully I do better. So I'm creating a function or an equation of a line. I need a slope and a b. To find the slope of this line, I'm going to use the y2 minus y1 formula over x2 minus x1. My y2 minus y1 is going to be 29,500 minus 28,000. My x2 minus x1 is going to be 10 minus 8. And when I do this, I get m equals to 1,500 over 2, which is 750. And basically this 750 means the enrollment is growing at 750 students per year. The thing that says assume the growth is linear, that means the change in the number of students is constant, that it goes up by the same amount each year. And that number is 750. Now I'm going to find my b. To find my b, I'm going to use the equation y equals mx plus b. Into the equation for m, I'm going to plug 750. And for x, I'm going to use the top. Well, I'll use the bottom point because I like using the 10. And for x, I'm going to use 10. And for y, I'm going to do 29,500. What I needed to do is pick a point along with the slope 750, plug them into the equation. You could have picked 8 for x and 28,000 for y. You'd get the same b. So I don't have room up there. I'm going to shove it down here. I'm going to go y of 29,500 equals m of 750 times x of 10 plus b. Now I'm going to do the math. I'll get 29,500 equals 7,500 plus b. Now I'm going to minus 7,500, minus 7,500. And I think I can do this without my calculator. I think I get 22,000 equal to b. So the equation that I need in part A, I can write for an answer y equals to 750x plus 22,000, and that's a linear, it's an equation of a line. It's also a function because it would pass the vertical line test. It's a linear function that models the data. This is a completely acceptable answer to this equation. Probably not the answer that is the ultimate best answer because I didn't use in my answer function notation, and that y can maybe be improved upon. I might do this. Call the y e of x, which means the enrollment for year x, equal to 750x plus 22,000. That's probably a better way to answer question part A, but y is fine. So something like this would be fine. As long as you have the 750x plus 22,000, what you have to the left of the equal sign isn't crucial. To do part B, I'm going to estimate the enrollment in 2013. For the year 2013, I'm going to use 13 for x because my years are going in the x coordinate and I'm not using 2008, 2010, and 2013. I'm truncating. And so to find the enrollment in 2013, I'm going to plug 13 in for x into the equation that I created. I'm going to go 750 times 13 plus 22,000. And whatever that comes out to be will be my enrollment. So I'm going to go on clear 750 times 13 times 13, really, 750 times 13 plus 22,000, and I get 31,750. So the enrollment in 2013, or the estimated enrollment in 2013, is 31,750 students. And that's the best I can do for an answer to part B. So that one is classically, it gave me 2 points, and I used the 2 points to come up with an equation for a line. I understood that part B wanted me to plug in something for x and to get the attendance. 18 isn't good for either of the strategies, coming up with an equation being clever or coming up with an equation by creating 2 points. There isn't an easier way to do it. So I'm just going to do the 2-point strategy and see how that works. So as I read through the first sentence, a school district purchases a copy machine for $10,000. After 10 years, the equipment's worth $500. It'll have to be replaced. Assume the value of the equipment goes down by the same amount each year. What I'm going to do is I'm going to come up with 2 points. And these points are going to be a little trickier to come up with because I don't see 4 numbers. My points are going to be similar. I'm going to do a year and a value for my 2 points. And my year isn't going to be like 2010. It's going to be year 1, year 2, year 3. And very specifically, I know that in year 10, after 10 years, the value is going to be $500. So this sentence that says after 10 years, the value will be $500, that gives me a point that's an obvious point. The first sentence says they purchase a copier for $10,000. That $10,000 is a value that's appropriate for the value part of a point. And to the left of that, I need a number that stands for the year. And that's actually going to be year 0. If you buy something, you've owned it for 0 years. After 10 years, you've owned it for 10 years. The big trick to this is to know that the value, the time that goes next to the $10,000 value is 0 years, because I haven't owned it for any years yet. If you get that, decide that you want to make points in the form year comma value, and you get points, then you should be okay. So now I'm going to do this. I'm going to find my M and my B. So first I'm going to find M by going y2 minus y1, which is 10,000 minus 500, over x2, which is 0, minus x1, which is 10. This is going to give me 9,500 over negative 10. And that's going to give me negative 950. I didn't need to use a calculator to do that because I just did it when I did the poor video. Now I'm going to find B. I'm going to use the bottom point to find B because it really does give me the B. So I'm going to find B by using the equation y equals mx plus b. In for m, I'm going to plug that negative 950. In for x, I'm going to plug 0. In for y, I'm going to plug 10,000. Again, I'm using the second point, but I could use the top point. So I'm going to go y of 10,000, so this is doing that, equals to m, which is negative 950, times x, which is 0, plus b. And the beauty of using that point is 950 times 0 is 0, so I get b equal to 10,000. So now I'm ready to write my equation, my answer to part A. I'm going to leave myself a lot of room to do that. And I could go y equals to mx, so negative 950x, plus b, which is 10,000. Or I could use a function name. If you had the desire to use a function name, you might say value v of x equals, and then the same, negative 950x plus 10,000. Doesn't matter if you use a function name or if you use the letter y. Now I'm going to answer, so I've answered question A in a y fashion and in a function fashion. The function is probably better, but I'd live with the y. Part B, find the value after 3 years. Because the x stands for the number of years, I'm going to plug in 3 for x into my equation, either the top or the bottom, it doesn't matter which. And I'll do it all in one line on my calculator. So I'm going to go negative 950 times 3 plus 10,000, and I get 7,150. And that tells me that after 3 years, the machine is worth, so the value of the copier after 3 years is $7,150. So that's the answer to part B. That's all that's asked for. 20 is another problem where it's just set up nicely to make points. 22 and 24 are not set up so nicely, and I won't be able to do those with points so well. I needed to change this number. So as I read through problem 20, and eventually I'm going to fix that so you don't see that 50 there. A real estate office manages an apartment with 1,000 units. When rent is $600 per month, 1,000 units will be occupied. When the rent is $700 per month, only 800 units will be occupied. Assume the relationship is linear. Write an equation. So if I just, this first sentence, although it's nice, tells me we only have 1,000 units. The next 2 sentences are what I'm going to use to get points. And my points are going to be of the form the amount of the rent, so the dollar amount of the rent, and then the number of units that are going to be occupied. And if I do this, the first sentence that I haven't crossed out says if rent is $600, 1,000 units will be occupied, and then it says if rent is $700, 800 units will be occupied. So I'm using this to make 2 points. I barely have any room, so I'm going to dig out another sheet of paper and do the computation to get my equation on another sheet of paper. So I'm going to find the slope by going y2 of 800 minus y1 of 1,000 over x2 of 700 minus x1 of 600. This gives me negative 200 over 100, which is a lovely negative 2. That's half of finding my equation. Gives me the demand in terms of the price. I don't like the way I just worded this. Finding the demand in terms of the price. I'm going to cross that X out so you don't see that X when you read this yourself. I need to make some notes to myself about equation for the demand in terms of the price. That's fine. That's what I just did. I did an equation that found the demand in terms of the price that I'm not done with yet. So now I'm going to find B. And to find the B, I'm going to use the equation y equals mx plus b. And in that equation, I'm going to plug m for negative 2. And I can use either point. I'm going to use the top point. There isn't any reason. The top point isn't any better or worse than the bottom point in this case. So I'm going to use x equal to 600, y equal to 1,000, m equal to negative 2. And when I do that, I get 1,000 equals negative 2 times 600 plus b. So it gives me 1,000 equals negative 1,200 plus b. I add 1,200 to each side, and I get 2,200 equal to b. So I have m equal to negative 2, b equal to 2,200. I'm going to put those in the equation y equals mx plus b and write my answer to part A. So for part A, I can say y equals negative 2x plus 2,200. That would be perfectly fine. Told me to use p for price, and maybe I can make that x a p because price is what the x coordinate is. And the classic way to write this, it says find the demand based on the price. Doing this, writing negative 2p plus 2,200 equals d of p is a really mathematically proper way to write this. I'd live with either. The bottom way is a nice way to kind of understand. This says the top doesn't tell me anything. It says this is the equation that goes through those 2 points, but the bottom says I can tell you the demand or the number of units rented based on the price by using that formula. If I plug in the price for P, I get the value or the number of units. So part B says use the equation to figure out the number of units occupied when the price is $6.75. To do that, I'm just going to go find the demand at $675, and I'm going to go negative 2 times 675 plus 2,200. It says round if needed, but I'm not going to need to round. I'm going to do this whole computation in one quick line here. So I'm going to go negative 2 times 675 plus 2,200, and I get 850 units because the y that comes out is the number of units. So I get the demand, or the number of units are going to be occupied. It's going to be 850 units. This fits just like the first couple of problems that I did. The next question is different. The part C is unlike any of the questions I've been asked before. The word problems, the last 2 word problems had part A and a part B, and I was done. This part C says at what price would 950 units be occupied? What I need to do is change the Y, which is the number of units, or change the demand, the D of P, to the number of units. So to do this question, the 950, if I plug that in for P, that would tell me what the demand would be at a price of $950 per month, but it wouldn't tell me the price. So I'm not plugging that 950 in for P because it doesn't stand for price. it stands for the number of units. So I'm plugging the 950 in for the number of units. And now I'm going to solve for P. I'm going to minus 2200 from both sides. And 950 minus 2200 I probably could do in my head, but I'm going to use my calculator. This gives me negative 730 equals to negative 2p. I'm going to divide both sides by negative 2. And again, I'm using my calculator. I'm not showing it, but I'm assuming you can do that. And I get 365. So the number of what the price that would cause 950 units to be occupied. That's not right. I messed up. 950 minus 2200 was supposed to be minus 1250. This right here should be minus 1250. I can't use my calculator right. And when I divide by 2, I get 625. So this is going to give me 625 equals P. So if the rent is 625 per month, 950 units will be occupied. So the answer to part C is the $625 per month for the rent, which kind of makes sense. At 600, all the units would be occupied, and when I start raising the price, I'm going to start losing some occupancy. The next two and the last two word problems that we have to do, they're classically set up so that if I try to use the 2-point strategy, I'm really going to slow myself down. And I can, both the problems 22 and 24, they give me some sort of a sentence that only has 2 numbers, which makes it kind of classically hard to get 2 points because you need 4 numbers. And they're written in such a way that they give you the equation without telling you it specifically. So as I read problem 22, it says a truck rental company rents a truck for $20 per day plus 60 cents per mile. And it says write an equation that gives you for the cost for renting 1 day. And I'm going to use a nice notation. I'm going to do this notation. I'm going to write an equation for the cost based on the number of miles. I could use M for miles. And I'm using a nice function name. It told me to use C for the name. And I'm going to write an equation of a line that's $20 per day. I'm only doing this for 1 day, so it's $20 plus the cost per mile. And the cost per mile is 60 cents, so 0.60 times X. If I did 60X, that would be $60 per mile. So this is the equation. It's right there, $20 per day plus, there's the plus, and then 60 cents per mile. The per I'm going to multiply by the number of miles. And because I'm only doing the cost per 1 day, I don't need to be like, I don't need a letter after the 20. It could be 20D plus 0.60X if it wasn't for just 1 day. But because I'm only renting for 1 day, this is a perfect cost function. 20 plus 0.60 times X, that's the $20 per day plus the 60 cents per mile. And that's it. So it just gave me the equation without any need to come up with points. And now I'm going to answer the questions. Part B says, what's the cost if 200 miles were driven? Because 200 stands for the X, because the X's are the miles, I'm going to go, the cost for 200 is 20 times 0.60 times 200. So my mileage is going to be, well, 0.60 times 200. Should be able to do that, but I can't right now. I'm paying $120 for the miles and $20 for the truck. So the cost is going to be $140. My mileage cost is 60 cents a mile times 200 miles or $120 plus the daily charge of $20. So my cost for part B is going to be $140. And then part C, assume I had to pay $80. How far did I drive? Well, that $80 needs to be involved in my algebra. I'm going to use this equation to get the answer, and the 80 stands for the cost I'm trying to solve for the number of miles. What I'm going to do with the 80, if I put it in for X, that would give me the cost of 80 miles were driven, but it's not 80 miles, it's $80. What I'm going to do in part C is replace the cost with $80 and solve for the miles that gave me that cost. So the equation that needs to be solved in part C, if you put the 80 in for x, that's saying you drove 80 miles. You want to find the cost for 80 miles. Putting the 80 into the left side of the equation tells me the cost was $80. How many miles did I drive? And to solve this, I need to do two steps. After I plug the 80 into the left-hand side, I minus 20, then divide by 0.6. And then on the left-hand side, I'm going to get my answer, which is 60 divided by 0.6. Too many 60s there. It gives me 100. On the right-hand side, I get the x. So if you drive 100 miles, you're paying 60 cents a mile. 100 times 60 cents is $60 for the mileage, plus $20 for the regular daily rental. That gives you the $80. So the answer to part C is you drove, or 100 miles were driven. Something like that. Now we'll go to the last problem. The last problem, the equation works just exactly the same way. If you look at this, the sentence is structurally the same. I only see two numbers in the sentence. I want to come up with an equation, and it's written. It tells me what the equation is. I'm paying $10 per month for my phone plus 3 cents per minute. I'm going to do the same thing. I'm going to say the cost in terms of the number of minutes, where x is the number of minutes. In the last problem, the x stood for the number of miles. And the cost is $10 plus, if I did 3x, it would be like $3 per minute. I need to do 3 cents, which is 0.03x. Part B, if I want to find the cost for 300 minutes, the cost for 300 minutes is your monthly cost of $10 plus your minute cost of 3 cents times 300 minutes. If I do 0.03 times 300, I'm paying $9 for my minutes. So I'm paying $10 for the monthly fee. My minute charge is $9. So the cost is going to be $19. And then the last part, C, it says, well, if my bill is $40, how many minutes did I talk? Well, if I paid $40, if I plugged $40 in for X, that would be like, if I talked for 40 minutes, how much would it cost? Because the $40 is the cost, I need to replace the left-hand side of the equation, the cost side, with $40 and solve for the x that's on the right-hand side, because the x on the right-hand side stands for the number of minutes. If I solve this equation by taking the 2 steps necessary to solve it, subtracting 10 and dividing both sides by 0.03, I'll get the answer that I'm looking for, which is the x. And that gives me 1,000. When I do this, I get 1,000. I don't know if you're going to be able to see that, equals to x. So the answer is going to be how many minutes were used. And I'm not even writing a sentence, but I am attaching a word to my answer, because when you're solving a word problem, your answers need to make sense, and I need to know what the number stands for. So in the part B, I put a $sign because the 19 stands for $19. For here, the 1,000 stands for minutes, so I wrote the word minutes next to it. So hopefully that was a reasonable lecture on those word problems. If you didn't feel good about that, then come visit me. I can make up some more word problems for you to practice so you can get good at them. The next section is all word problems as well. In some sense, they're even friendlier than these problems. They look way more complicated, but the stuff that is complicated, we're going to use our calculator to solve. So it's going to be a friendly-ish section, but you'll absolutely need to have a TI-83 or 84 calculator when you go through those sections, because the keystrokes I'm going to show are I'm not going to show how to do the problems by hand, and without that calculator you won't be able to do what you need to do.